Good. So as you probably have noticed, the cosine of theta for small angles and for small slope grades uh, is always very close to 1. It's almost 1. That's why we can assume that cosine of theta is almost 1 in this equation, so that the rolling resistance can be um, equal to friction times just the weight of the vehicle. And then there's a way to calculate or estimate the coefficient of rolling resistance or the friction, uh, which is a function of the vehicle speed. If you have your vehicle speed in feet per second, you can calculate the coefficient of rolling resistance. That's F sub RL equal to 0.01 times 1 plus v, the vehicle speed in feet per second, divided by 147. So this is very useful in calculating the rolling resistance of different traffic conditions and different vehicles traveling at different speeds on the vehicle, on the road surface. And as you see here, the rolling resistance is directly affected by the friction and weight of the vehicle as well as the speed. If you want to take this a little bit more advanced here, uh, we have another uh, type of resistance force, which is uh, the resistance force from the normal component, from the parallel component of the weight of the vehicle, or that's why we call this is the parallel component. That's why we call it the grade resistance, and it's actually a function of the grade or the slope degree or the slope angle of the road surface. So basically the grade resistance is just the parallel component of the weight. So the normal component was W times cosine of theta that we saw in the previous slide. And again, from your basic algebra or calculus knowledge, the parallel component is going to be W times sine of theta. And again, if you do the experiment for small angles, if you do the experiment for the same range of grade angles or slope angles from 1 to 5 or 1 to 10, the sine of theta is almost equal to tangent of theta. Um, and we all know that the definition of the slope uh, is basically tangent of theta, right? So we can replace sine of theta with tangent of theta, and tangent of theta is basically the slope of the road, or the grade. We call it the grade. And grade is the definition of the grade is how much the road surface is rising over a unit horizontal distance. And since you're estimating the vertical rise in feet, and the horizontal distance also in feet, the grade is unitless, and it's basically in percentage. So example, or another very quick class activity. Let's say a roadway rises 5 feet in vertical direction over 100 feet horizontal distance, right? If you want to calculate the grade of this road, it's basically the slope of the road or tangent of theta, and that's going to be the amount of vertical rise, which is 5 feet, divided by the amount of horizontal distance, which is in this case 100 feet, and that's 5 over 100, or 5%, right? Now, quick question or quick class activity, what is theta in this case? So again, the question is, we have a roadway that rises 5 feet in the vertical direction over 100 feet horizontal distance, and we know that the grade is 5%. The question is, what is theta? And you can see theta in this picture.